Hammer throw problem from the notes. In this problem, an athlete whirls a 7-kilogram hammer tied to the end of a 1-meter chain in a horizontal circle. It takes the hammer 1 second to go around once, so we're going to find the centripetal acceleration of the hammer and the tension in the chain. Now we've already drawn the picture. Here's the hammer and the chain. The forces acting on that are the force of gravity and the force of tension. We have all of our givens here. The mass is 7 kilograms, the radius is 1 meter, the tension is 1 second. The acceleration and the centripetal force, or the tension, they are the same thing in this problem, is what we're looking for. So the first thing we're going to do is find the acceleration. We've learned in class that the equation for acceleration, when something is going around in a circle, is given by the velocity squared multiplied by the radius. We don't have velocity, but we do know the equation for velocity. That was 2 pi r over time. So I can plug in the equation, 2 pi r over time, in for velocity here. And I have to square that. So the 2 becomes a 4. Pi gets squared. There is an r in the top, and that's going to be squared, but that's going to cancel with the one that was in the bottom. So we just have a regular r there. And then the time in the bottom is squared. We can plug in our numbers and solve. We have 4 pi squared times 1 meter, all over 1 second, and that is squared. And when we plug that into our calculator, we would get an acceleration of roughly 39.5 meters per second squared. So that's one of our answers. Now we're trying to find the force of tension. Well, our force of tension is our centripetal force, which means any equation we have that describes centripetal force is really describing the tension. And we know that the centripetal force is equal to the mass of whatever is going around in a circle multiplied by the acceleration of it as it goes around in the circle. We have both of those numbers. So we know that the force of tension is going to equal 7 kilograms multiplied by the acceleration we just found of 39.5 meters per second squared. So we finish that up, and we know that the tension is 276.3 newtons. And now we're done.